All right, so we're going to talk about exponent rules. So for exponent rules, you will have this paper. It's attached in that email to you guys, or in that document to you. So exponent rules, just really quickly. When you are multiplying, when the bases are the exact same, then you're going to add your exponents. So for example, if I have x to the 4th times x to the 9th, that just means x raised to the 4th plus 9, or just x to the 13th. So in multiplying, we're going to be adding our exponents. All right, so then when we're dividing, again, same bases, so both are base A here, we subtract our exponents. So here would be 9 minus 4, so that's how we get x to the 5th. Negative exponents. So if we want to simplify expressions, you can never have a negative exponent left. So in order to get rid of the negative, what we do is we throw it to the bottom of a fraction and we lose the negative sign. So a raised to the negative x becomes 1 over a to the x. So for example, if you have x to the negative 10, that would equal 1 over x to the 10th. Okay? Something that you have to remember here is if I had 4x to the negative 2, the 4 is not attached to the negative exponent. So the 4 would actually stay on top, and then we would put x squared on the bottom to get rid of the squared, because the squared is only attached to the x, not the 4. All right, power to a power. So we have inside parentheses, we have a to raise to the x, and we're taking all of that and raising it to the y. So what you do is you multiply then. You will multiply your exponents. So x raised to the 4 raised to the 2, power to a power, multiply, so we get x to the 8th, okay? And then down here, so if we're multiplying inside of parentheses, and all of it's being raised to a power, so a times b, all of that raised to the m, we can break it up into pieces. So basically you're distributing the m, the power m, to both things on the inside. So then this becomes a raised to the m, b raised to the m. Okay, so an example of this. So we would take this 3 and it would go to both things in here, this to the 3rd power. So this becomes 3 to the 3rd, a to the 3rd, so that simplifies down to 27a to the 3rd, because 3 to the 3rd is 3 times 3, which is 9, times 3, which is 27. Okay, all right, and then power of a quotient. So doing the same sort of thing as we did up here, only now we're dividing. It's the same thing. Everything gets distributed. So this would be a to the m divided by b to the m. So if I have 5, 6 raised to the 3rd, that's 5 to the 3rd over 6 to the 3rd. So we get 125 over 216. Okay, same thing as if it were variables. Okay, so if I had 2x over y, all of that squared. So what that would mean is I distribute the squared to everything on the inside. So 2 squared, x squared over y squared. And then we always simplify if we can. So 4x squared over y squared. Okay, so that would go along with that example there. All right, and then the easiest one, 0 power. Anything raised to the 0 power is always 1. Okay, so the reason that is because if we had x to the 4th divided by x to the 4th, according to our quotient of powers rule up here, we subtract exponents. So if I subtract these exponents, I get 4 minus 4, that would give me x to the 0. Now you were taught a long time ago when you first learned division that if you had like 4 divided by 4, that's 1. Or 16 divided by 16, that equals 1. When you have the same thing on top as on the bottom, it equals 1. So here we have the same thing on top as we do on the bottom, so then this is going to equal 1, so x to the 0 has to equal 1. So x to the 0 equals 1, so 5 to the 0 equals 1. X, y, all that raised to the 0 would be x to the 0, y to the 0, which again would just be 1. Okay, so anything raised to the 0 power is 1. It's not the letter, right? So x to the 0 did not equal 1x, it equals just 1. So the letter's gone, the variable's gone. All right, so you're going to use these rules in order to simplify expressions. So you also have this paper, so I'm going to go over a few of these problems with you, and then you are going to work on the rest of them. Okay, so like for number 1, we're going to start off by multiplying your numbers. So 2 times 2 gives me 4. Now we're multiplying, which means we add our exponents. So then this would be 4m to the 5th. On number 2 here, Yes, this is a negative exponent, but before we start throwing things to the bottom of a fraction and all that stuff, getting rid of that, let's go ahead and add, because by adding, we might get rid of the negative. So 4 plus negative 3 gives me 1. So this is just going to be m to the first, or just m. And then we multiply our numbers. Well, there's really an imaginary 1 there, right? So 1 times 2 is just 2. So that's going to give me 2m. Here, we're going to multiply our numbers. 2 times 4 gives me 8. R to the negative 3 and r squared. So I'm going to add these. So that gives me r to the negative 1. But we can never have a negative exponent. So this right here, I have to put on the bottom of a fraction. Now my 8 does not become part of the bottom of the fraction. It's all by itself. So 8's going to stay on top, and then we have r on the bottom. Okay? If we skip down, so look at number 6. So here, 2 times 2 is 4. X to the third, x to the negative 1. So we're multiplying, so we're going to add them. That becomes x squared. And then y to the negative 3 and y to the third. So negative 3 plus 3 gives me y to the 0, which is just 1. I don't need to put a 1 here. I don't need to put times 1. Okay? As we go down a little bit further, so for example, number 13, this 4 gets distributed to both things on the inside. So this is where students make the biggest mistake. They forget to put the power with the number. So this is 4 to the 4th, and then r to the 0, because 4 times 0, power to a power, we multiply. So this right here equals 1. So then I just work out 4 to the 4th, which is 256. But I don't need to put times 1 because it would just be 256. Here, again, distributing the 2 to both things on the inside. So we get 4 squared. 2 times 3 becomes a to the 6. So 4 squared is 16, a to the 6. Okay? All right, let's flip over and look on the back. So let's look at number 20. All right, so on number 20, so we're going to distribute this. So this becomes negative 2 and m to the negative 2. All right, now a big mistake that a lot of students have been making lately is that they want to say that 3 raised to the negative 2 equals negative 6, which it does not, okay? So 3 raised to the negative 2, to get rid of this negative, we'd have to put it on the bottom of a fraction. So this becomes 1 over 3 to the second, which is 1/9. Okay, so this right here is going to be 1/9. Now, m to the negative 2. If we ever have a negative exponent, you put it on the bottom of the fraction. So this would be m squared down here. So 1 over 9m squared. Okay. If we look here on number 21, so there's really a 1 up here. We just don't see it, right? There's nothing I can divide the 2 by, so 2 is just going to stay on the bottom of the fraction. If we can't divide it, then just leave it alone. So then 2 minus 3 is negative 1. So to get rid of the negative, I put it on the bottom. And then just because I need something on the top, we put a 1. All right. As we move down, 26. So 2 divided by 3, I can't simplify that. So I'm just going to leave those where they are. So then I look at the x's here. We're dividing, so we subtract. So 4 minus 2 gives me 2. That's a positive 2, so it's going to go on top. Then we have negative 4 minus negative 3. So negative 4 minus negative 3. When we subtract a negative, this becomes plus. So negative 4 plus 3 is negative 1. Since the answer is negative, we put it on the bottom. And I can put a 1 there, but you won't typically see a power of 1. Then if we look at z's, we have negative 3 minus 4. So this becomes negative 7. So z to the 7th goes on the bottom because it was negative, so we put it on the bottom in order to get rid of the negative sign. All right, so it's just taking step by step, looking at one thing or the other, and then you're not just doing one of the rules, these exponent rules, you're actually doing multiple of them. Like you're going to do more than just one in a problem, okay? So try those out, see what you can do. If you have questions, feel free to contact me, and I'll be happy to walk through some of these with you.